Hello again, everyone. Sorry about the hiccup. So this talk is learning to succeed on large projects. My name is Denise. I'll quickly introduce myself as I've never been to this conference before, but I'm very excited to be part of the first fully online iteration. So by day, I work as a senior engineer at GitHub. Many of you have probably used GitHub at some point, and I'm happy to answer any questions about that at the end of this talk. I currently work on a team called Communities. We're building some really cool things to create and grow communities around open source software. I'll talk about some of the things we've done in a moment. Another thing that I really like to do when I'm not coding is I like to draw. Drawing and creating art has been my hobby since I was a child. And these days, I try to use those skills to make tech a friendlier and more interesting place for people by creating sketch notes and doodles related to technical concepts. And since we are in Portugal, I felt it would be wrong to not call out my love for Vinho Verde. So a couple of years ago, my family and I went to Lisbon, and for the last 5 years, literally the only wine I bought is Vinho Verde. So please continue to produce Vinho Verde. So a little bit about communities at GitHub. Sorry, I'm gonna just, okay, I realized my presenter notes are not turned on. A little bit about communities at GitHub. So this is the team that I currently work on, and I kind of mentioned that our whole mission is to make open source work more enjoyable and more sustainable for both maintainers and contributors. Some of the specific projects that we've worked on over the last few years that you may have come across includes GitHub sponsors. Sponsors is a program that lets maintainers of open source software projects receive funding for their work. So it's a little bit like if you've used Patreon or Ko-fi or funding platforms like that before, but this is specifically related to maintaining projects that are used by open source projects on GitHub. So if you currently work on an open source project that other people and companies rely on, you could consider becoming sponsored. Or if your company uses a lot of open source work, you could consider becoming a sponsor. And as an added bonus, GitHub, for the time being, matches sponsorship money 100%. So right now, if you sponsor someone for $100, we match them for another $100. That won't be around forever, so do consider jumping on the bandwagon sooner rather than later. Another thing we shipped last year is discussions at GitHub. So for a long time, maintainers and contributors could only communicate via issues or pull requests. Otherwise, they would have to go off platform to a place like Stack Overflow or Discord or Google Groups in order to have like conversations about things that are not strictly bug reports or feature requests. Discussions is our product that fills that gap a little bit. Discussions provides a community-driven forum so you can ask and answer all kinds of questions related to your project. So if any of that sounded interesting to you, of course, GitHub is hiring. We run internships. We have roles that are open all the time, and you can ask me any questions about this at the end of this talk. So enough GitHub plugging. Thank you so much for coming. This was a really difficult talk for me to write because I tried to target it towards people who are newer to the industry or have less industry experience than me. And as someone who's been around for almost 7 years now, it's been a long time since I first got started. So I've tried to design this talk in a way that assumes that you, the listener, have no experience in industry. So that means I'm going to err on the side of talking more about how real software teams work, because I want us to be on the same page about what the day-to-day experience is like in terms of working on larger projects. But I'm also going to assume that you have the infinite capacity to learn. So I'm not going to shy away from talking about difficult or complex topics. Hopefully, by the end of this talk, you'll feel more informed and you'll be more curious about what it's like to work on software teams in the real world. So I'm going to start a little bit on the deep end. All software systems are socio-technical. This is a word that you probably don't come across too often. I've become more interested in the resilience engineering space. So for those of you who are interested in things like site reliability engineering, I've become more interested in that space in the past few years. So I've been thinking about this term a lot, and I want to talk about what this term means. So a system's success relies on not only good technical specification, but it also relies on usability by humans. So by the end users, by the operators, by the people who maintain it, who build it, who have to keep it alive. I drew this comic of a person, kind of plugging in a USB a while ago because I thought it was kind of funny and relatable. But I also think that this is a really great metaphor for thinking about systems design. So USB as a standard is extremely popular. It has super, super high adoption. You can use a USB stick in anything. You can use it in a car, in a smart fridge. So in terms of its technical specification, right, the USB is an API that is well designed and it's well socialized. But how many of us make this mistake every day, right? You try to plug it in, you're like, oh, I'm wrong, turn it 180 degrees, wrong again. Like, oh, I was right the first time. So like I make this mistake literally every time I go to plug in a USB. So the point I want to make here is that the system designer's job, and we're going to be talking about systems a lot today. So everyone is a systems designer when you start writing software. The system designer's job is not done until we think about how humans are going to interact with the tools that we've built. And building software systems is no different. So I'm going to frequently return to two themes throughout this talk. The first is technical capabilities, and the second is social behaviors. These are two complementary competencies that we'll need to build in order to become better at learning and building and architecting large systems. Neither of these capabilities is more important than the other. Neither is better than the other. We need both to be successful. I want to spend a few minutes level setting and talking about how software teams typically function in industry, because I don't want to assume that everyone has worked in a professional capacity before. So as a general rule, no matter what kind of company you end up working at, the one constant feature will be the backlog. This is your main project management tool. This is the thing that tells everyone on the team like what needs to be done, who's currently working on what, and what's already been accomplished. So interestingly, the word that your team uses to refer to each individual item in the to-do column will be different based on the company you work for. But the reason why it's different is because companies use different tracking tools. And I want to add this as a clarification because I use a different term than probably what other people use. And I just want to say like these are all terms for the same thing. So if your company uses Trello, you'll probably call them cards. If your company uses Jira, you'll call them tickets. If your company uses GitHub and GitHub projects, you'll call them issues. In other places, I worked at Pivotal for 3.5 years before I went to GitHub, and we called them stories because Pivotal Tracker called them stories. So I use the word stories because it's burned into my brain from 3.5 years. But I also kind of like the term story rather than like card or ticket or issue, because a story has like a positive connotation, and stories can be told and completed collaboratively. And I think that software development should emphasize collaboration more than just like getting stuff done. But I want you to know that all of these words are the same concept. So your main output as a new engineer will be writing code. You'll take a story and you'll turn it into code. How does that work? Let's take a look at what one typical story might look like. Here's a fairly realistic example. This is something similar to what I worked on at GitHub. Imagine you have an existing API endpoint and it's currently returns some information. We want it to return a little more information. So the story should describe what the intended change is, and it should ideally give some context about what we currently know about the world, like how we might be able to fetch that information so that we can then serve it up to the end user. So ideally, every story would have a couple of characteristics, and like this is ideal world. Things are going to be a little more all over the map because humans, basically, because humans and time and constraints is something else we'll explore later on. So some of the characteristics of well-written stories are that it should be validated. That means that someone, usually a product manager or a product owner, has gone and confirmed that this would actually be useful for the customer. A good story should also be clearly scoped. So that means as an engineer, I should be able to know when I'm done with the story. And a story should be broken down into subtasks if you need it to. Sometimes stories take a while to complete. That's fine. That's just kind of the nature of working in software sometimes. But if it's something that's going to take more than a couple of days, I really, really, really like for a story to be broken down so you still feel some forward momentum. You're not just kind of like swimming in the same story for multiple days on end. And the final characteristic is that I think that when a story hits the backlog, it should have more known knowns than unknowns. And so this is when we're going to dive a little bit into the theory of knowledge. It's going to get a little philosophical. So I think about knowable things. So I don't know how many of you have taken philosophy classes or studied epistemology. I did. I didn't study computer science when I was an undergrad. I studied philosophy. So theories of knowledge. I think it's more nuanced than this if you actually go into the literature, but I like to think of knowable things as belonging in one of three buckets at any given point in time. So either something goes a known, which means that if you're thinking about in terms of technical work, I know how to do this, I've done this before, or I clearly know where I'm going to copy and paste from, something like that. Or something can be a known unknown, which means like, I don't know exactly how to do that, but I know what questions I'm going to need to ask, and I know what I need to go out and find out before I can do it. Or things can be in a third category called unknown unknowns. And things are hard to reason about when they're in this category because you literally don't even know the questions to start asking. We're going to come back to this in a little bit. But if a story contains more unknowns than knowns to you as a junior engineer, as a new engineer, there are a couple of things you can do. The first is you probably just need to ask for help. If your company has a culture of pair programming, I think pair programming is like the #1 way to pick up technical context. I think this is the best way to get help, frankly. I pair programmed for 3.5 years when I worked like every day when I worked at Pivotal, and I learned probably more in a day there than I would in a week on my own. So if you have a strong pair programming culture, or if you have the safety to ask another person to pair program than you, that would be my #1 recommendation. But if pair programming is not in the DNA of your company, or you don't feel comfortable asking for that, you can just ask questions during team syncs. Virtually slide your chair next to someone else's chair and ask them some questions. Like in today's world, we'd probably just like Slack someone in a DM rather than your team channel. But keep in mind that you're probably not the only person who's confused. But there's a third option that I want to call out here because I think a lot of new engineers don't even entertain this option. The third possibility is that a story might actually just be poorly written. Not poorly written, sorry. A story might actually just not be ready to work on. So as a newcomer, asking questions about what needs to be done is actually incredibly valuable to the team. Because sometimes like people who have been around for a lot longer, we write stories that are really high in domain context or contain way too many subtasks that we haven't broken down, because we forget what it's like to be a newcomer to the project. So asking for clarity so that you can do your job is actually a really great way to prompt the rest of the team to be more disciplined about the software development process. But I want to talk for a second about stories that are actually too big, because this is a big problem. And I don't think that this is like not something I was equipped to deal with early career. I wish I had learned the art of breaking down tasks much earlier. So I'm going to show you how I think about this now. I like to think of, there are a lot of different ways to break down work, by the way. This is just how I like to do it. I like to think about the project, the application as being like a cake with many layers. The layers represent different parts of the application stack. Imagine that some layers are client-facing. You have like maybe a React.js app that provides a rich web interface, and a couple layers down, you have your data layer, like your object relational mapping layers and your database drivers and that kind of thing. This like client API data model is a pretty common one. I think this is how most modern applications work. So once you start working on a project, you're going to build some knowledge of what these different layers are. Of course, they'll be different for every application. One way you can break down a story is to think about slicing it down horizontally. So figure out what changes need to occur at each specific layer, deliver those changes independently. Sometimes when you use this strategy, you're going to need to think about a release strategy to make sure that basically means like you have to think about compatibility upwards and downwards of the stack. If you change something randomly in the API and the client is expecting to send a different payload or receive a different payload, that could cause problems. So you're going to need to think about a release strategy sometimes when you do this. An alternative is to vertically slice a story so that it doesn't matter how many layers of the stack are affected. We only care about one end-to-end change. But these changes can be incremental. It doesn't mean that we do everything at once. So go back to the example of like adding more information to an endpoint. You can imagine a couple of different vertical slices here, right? So let's say like, well, first, maybe let's set up an extra element in the payload. We return something extra, but it's empty. We just prove to ourselves that we're able to expand the API at all. And maybe in a second round of changes, we actually deliver the data that the customer is looking for, things like that. I personally prefer vertical slicing because I think that this method of breaking down work keeps me focused on what I'm delivering to the end user. But if you're just trying to get a story to be smaller, I think both of these strategies are valid. So now that we've level set a little bit on how teams work, I'm going to start talking a little bit about how we can be successful on our first large projects by talking about some personal truths that I have had to grow to accept over the past few years. But first, like, how large are we talking? Like, how large are large projects? So the definition of a large code base is going to be very different across different organizations. What I'm interested in exploring, though, is like, at what point do I have to start to change my behavior? And so that's what I'm going to look at here. So generally the point at which I have to change my behavior in terms of learning about what the code does is when a project has over 100,000 lines of code. But that is, again, rough figure, depends on your language. Some languages have more white space than others, right? So like, that's a very, very rough approximation. I think a more interesting metric is the rate of change. So I think that if a code base is changing by more than about 100 commits landing in the default branch each day, that's when you have to start shifting your mindset. At GitHub, we have probably between 1,000, definitely upwards of 1,000, sometimes up to 5,000 commits landing in default each day. So that's a lot. Usually it's not 5,000. I think it's between 1,000 and 2,000 changes each day land in the main branch. And we have like many, many different teams all working on the same code base. Typically, all the code will be in one. For large projects, typically it'll have a mono repo, or it'll use the monolith pattern, which means that all the code lives in one repository. But this isn't always true. Even if some teams have split out their monolith into different services, depending on how accurate their guesses were about the correct boundaries to break things down, you may or may not have to still be looking at multiple code bases. Doesn't matter a huge amount. I think that a lot of the strategies for learning are still going to be true. So the first truth that I've learned is that most production code bases will change faster than a human can learn all of it. That's fine. We won't need to know all those parts at once, but I know this can be a jarring realization if you've only ever worked on smaller code bases or side projects. The second realization is that I will encounter decisions that I disagree with. Like, I would not have written the code that way. I break down these disagreements into two broad categories. Sometimes they're about hygiene, right? And by hygiene, I mean kind of like the cleanliness of the code, kind of like the micro decisions about organizing and naming code, like conventions. So maybe like this code didn't follow the conventions. Maybe this code wasn't refactored enough to my liking. Maybe there's some duplication that I would have gotten rid of. So that's all kind of like around the hygiene of a code base. It might not meet my personal standards, right? But the second set of disagreements that I often have is like around the actual design. So I actually have opinions on what, like I would have modeled the system differently. I would have modeled the business domain in a different way. I would not have set up this class. I would not have given that class these methods, like that sort of thing. So these are all around like design. I'm going to return to that also later. So the third thing that I realized is that reality, just like living life and trying to do our jobs, is the thing that leads to the accumulation of technical debt. I'm going to show you how. So in a large code base, you're very often going to come across code that looks duplicated. You're in two different files. It's like, oh, these two files have methods that do exactly the same thing in like slightly different ways. So things that look like they're duplicated, things that look like they're oddly named, like they don't belong. So this is actually a feature and not a bug of large code bases. The reason that duplication and small kind of code smells exist in different parts of the code base is, the reason for that is actually very, very simple. It's because two different teams wrote those pieces of code and they didn't talk to each other while they were developing. Coordinating things like method names and duplicated logic and small things, like that doesn't sound so hard on paper, but when you have enough people pushing enough changes into the same code base enough times in a day, then the cost of coordination, so this is called the cost of coordination, that gets very, very, very high. Imagine if you have to go talk to another person every time you want to name a method or every time you want to write a test. That is enough to slow down your development velocity to the point that it's not worth it for most organizations. So we consciously decide that the cost of coordination is too high and we're going to tolerate technical debt. So we're going to tolerate duplication and bad naming and the lack of refactoring in the meantime. So I'm not defending the practice of taking shortcuts all the time, but I just want to show you that humans and teams are always making decisions under constraints, under the constraint of reality. So no decision we ever make will be perfect, and we're going to see the artifacts of that in the code. And that's okay, because we're all human. So large projects you're going to find that large projects follow many different sets of design guidelines. It might feel like there's not even a style. There might be a style guide, but there's the application of that style guide will be inconsistent, I promise you. Because people make decisions under the constraint of limited information and limited time. The outcome is going to look weird. As a new engineer, you don't have to fix it. In fact, I would actively advise you not to try to address duplication in different parts of the code. But instead, like, we just have to learn to work with it. How? And of course, like, that's the main part of this talk. And I think that learning large amounts of information essentially comes down to one skill, and that skill is context management. I think that we should always be always shifting towards known knowns. So again, to return to this categories of knowledge concept from earlier, everything that we will ever learn begins as an unknown unknown. So at this stage, we're not even aware that a new concept is a thing that we could learn. If we become aware that a concept exists and we don't know it yet, then that's a great thing, because that's a positive development. That's a shift towards the left in this taxonomy, at least. It means we've shifted it into a different bucket, and now it's a thing that we can go and learn more about. Another thing I want you to notice that things don't typically go from unknown unknowns over to known knowns. They have to live in the middle for a little bit, because learning is a gradual and incremental process. As we learn more about the code that we're working on, about coding in general, there typically is a point where we feel like we've accumulated all of these known unknowns, right? Like, there's so much to learn, we're feeling overwhelmed. We start to realize how much we don't know, and we start to lose confidence. There is a model for this. In social psychology, the Dunning-Kruger effect model states that at the beginning of learning something new, we often have high confidence. We're kind of they call it the peak of Mount Stupid, because we only know a couple of things, right? There are only a couple of things in our known unknowns bucket, the middle bucket, and there are a few things in the green bucket. And we feel great about those things. But as we start learning more, we start realizing the depth of all the things we don't yet know, and we start feeling despair and frustration. But if we keep at it, then we eventually get back to a state where we're more comfortable about our level of knowledge again. So this sort of like fall into the valley of despair happens to me about like 3 to 6 months into a new job. I usually feel great for the first few weeks because I don't actually know anything, and then I start feeling really bad. But I think a sign that we're learning more is that we get to that point. Of course, it's not nice to be there. It really sucks to be there, right? So how can we start to climb back out? Well, earlier, remember our long chat about backlog management. So partly that was to tell you how software teams work in the real world, but also I think the practice of breaking things down and being strategic about what to work on next is also highly applicable to the process of learning. So this might sound super obvious at first, but when you learn a new code base, you should prioritize your team's domain. Odds are your team will tend to write code in certain corners. You'll have a couple of files that you touch more than other files. Focus on understanding those pieces first, because that's most likely to be relevant to the stories that you'll be picking up. And try to ignore the rest of it for as long as you possibly can. But of course, like, I know people are curious. We're engineers. We like to go down rabbit holes. Sometimes we can't resist the temptation to like go and explore something that looks cool or looks interesting. So I would say that if you're going to explore beyond your team's immediate area of ownership, make up rules for yourself. Say that I will follow this thread for 2 hours, but then I'm going to stop myself. I literally set a timer, stop myself, and then reassess whether it's actually valuable to continue. So reassessing might mean like, okay, I'm going to take some notes and then review my notes, or I'm going to go talk to my teammate and say, hey, I've been looking at this for 2 hours. Do you think this makes sense for me to keep doing? So come up with rules. Like, don't let yourself get stuck in these rabbit holes for days on end. I don't think that that's a productive thing for new engineers to do. I also think that after a little while, you'll kind of find behaviors that work for you. So I like to develop a ritual for making sense of new files. What I always do is I open the source code and I look for corresponding unit tests. That's the first thing that I read, because I treat tests like documentation. Hopefully, like the company you work at also has a culture of like treating tests like documentation. But of course, like that's not always true. Sometimes people don't write tests. So the next best thing is to look at the file's Git history. Hopefully use version control. Try to get a sense of what's changed recently and why. And if that fails, then this is like even more shot in the dark, but look for corresponding documentation. Look for like conversation on Slack. Look for email threads. Look for GitHub issue threads. Look for pull requests where that code might have been put in. Look for requests for comment. Like maybe companies have a culture of doing that. Like they'll send in a document about a proposed change and ask other people for their comments on it. Otherwise, if all fails, if there's like absolutely nothing else, my best tool is a piece of paper and a pen. So I just start making diagrams. I try to model all the domain entities and how they interact with each other. The second thing I want to talk about is is complexity. And I think that complexity can be divided and conquered. So what is complexity? Complexity is actually really, really hard to define. It's kind of one of those like, there are, of course, like dictionary definitions for it, but rather than trying to define what it is, I'm going to talk about how it affects us. So complexity requires us as engineers to do more work to build understanding. So that means that the more relevant context you have, the less work that you have to do. And of course, when we start out, we have no relevant context. So we're always going to be swimming upstream through a lot of complexity. Oh yeah, sorry, I said that part already. So yeah, new engineers are always going to be working through a great deal of complexity. But the good news is that not all complexity is equal. And you actually can break down complexity in service of how we learn about it, of how we prioritize what to learn first. So there are two types of complexity. There's inherent complexity and there's incidental complexity. Inherent complexity is unavoidable complexity because it's tied to the underlying business domain. So all software that you write for production code bases is going to be, that software exists because it serves some business purpose, right? And like, so there's an underlying business domain. One really good example is tax software. I think, I don't know about Portugal, but in the US, the UK, and Canada, which is the countries where I've lived, tax policies are really complicated. So if you're an engineer writing tax software to help people pay their taxes, it's just going to have a certain degree of unavoidable complexity. On the other hand, incidental complexity is different from inherent complexity because incidental complexity is not related to the underlying business domain. And as the code base grows, though, it will naturally accumulate incidental complexity because you have a lot of people making a lot of decisions with different levels of information. In some cases, incidental complexity is avoidable. In some cases, it's not. Or in some cases, it costs more to avoid than it would to tolerate. And of course, like that trade-off is generally only true to a certain extent. It's really hard to see what that tipping point is for most software projects, though. I think that understanding why a problem is complex can help us to break it apart and conquer it. So once we separate out, so if you're really stuck on something, it's probably because there's both inherent and incidental complexity at play. So once we can tease apart the different types of complexities, I think that helps us reason about how we solve a problem. So I don't want to make a blanket statement about which type of complexity is more worthwhile to work through first, because that totally depends on what you're working on in your domain and your team and your goals. But I think that having this framework and keeping in mind that there are different types of complexity can help you make a problem feel smaller and help and break it apart more. And the final thing I want to end on is to be curious. I would encourage you to be curious as much as possible, not just in the beginning of your career, but throughout your entire career. Fresh perspectives are incredibly valuable to teams. I kind of talked at the beginning of this about how this talk was hard for me to write because I don't have a fresh perspective anymore. People who've been working in the same space for a long time forget what was hard or what was unusual when we started. So in other words, like we've forgotten how to solve a problem with fresh eyes, but that is the thing that you do best as a new engineer. Your most valuable contribution in your first few weeks is that you ask the best questions. Like you ask the questions that other people don't even think to ask because we've been so deep in the weeds for so long. There is no safer time to ask for extra help, especially than your first few weeks on the month, or your first few weeks on the job, especially when your request for help is motivated by your desire to learn. So a really great format for asking questions that a junior engineer that I once worked with, who is now a very successful senior engineer, she used to use this phrasing a lot. She would say, "For my own learning, could you explain more about something?" Or like, "For my own learning, could you say more about, why you implemented it this way?" Like whatever. But if you preface it with "for my own learning," I think that's such a great way to open a question because it so clearly sets the motivation and it makes it hard for someone to say no, which I think is brilliant. I actually use this phrase now too, and I think that everyone, like regardless of your career stage, I think everyone can afford to be more curious. I also this is not strictly related to being on a team, but I think that it's really beneficial to actually set aside some dedicated time to do some reading. So I like to block out like 1 or 2 hours on Friday after lunch when I'm not going to get anything productive done anyway to like read internal documentation, catch up on conference talks, do whatever it is that supplements your on-the-job learning. My final thought on the topic of curiosity is that I think if you allow yourself to be curious, I think you'll eventually hit this inflection point. In the beginning, you're going to be pretty confused by what to work on, and you'll need a lot of guidance, and you'll be asking a lot of open-ended questions like, what should I do next? Like, what should I look at? You'll need a lot of guidance. But at some point, I think you'll start to understand what your team's priorities are and how your work fits into the bigger picture. And I think that the inflection point is when you stop asking, what should I do next type questions, and instead start stating rather, this is not even a question, I'm going to work on this thing next. Let me know there's something more valuable for me to do. And I think like, even if you're not at this point, it's good to just try this out. Just try like having an opinion, choosing a direction, and making it, and then being open for correction and feedback. I think this is, I don't know, I've seen this turning point a couple times in people, and I think that this is great to see. But starting to develop opinions and being open to feedback is like one of the best competencies for new engineers. And the final thing, I'll quickly talk about this, I'll sneak this in. I think a really great thing to do is to track your momentum, because there will be days and weeks when you feel like you've made no progress, but you actually have. And the best way to keep feeling that forward momentum is to write stuff down, create an achievement log. I literally have a document on my computer that's just like OSX Notes app. And I like put some bullet points into it every week about what I've done. So each day before you log off, spend 5 minutes, just 5 minutes, writing down what you worked on and what you've learned. And look over that document at the end of every week. If you want, you could share this with your manager, but you don't have to. So this is my recommendation. Having an achievement log that just documents everything I've done during my first few months on a job. I'm not a junior engineer anymore, and I still do this. I think this is such a useful thing to do. So in summary, always think about your learning as shifting towards known knowns. Think about dividing and conquering inherent from incidental complexity, and be curious and track your momentum. You've all got this. I can't wait to see you in our industry. And I'll pause for questions for the next 8 or 9 minutes. But thanks so much for coming. It was great to be here. Should I stop screen sharing? Maybe I should. I don't know how. Okay.
All right, everyone. Denise, thank you so much for your talk. It's very good. We're seeing some questions up here in chat. Denise, you can take your pick.
Oh, okay. Let me flip over to the correct. I don't know if I'm in the right place.
It's called Main Stage by Everest.
Oh, okay. I see. Cool. I can't choose this. Do you want to choose a question, Joao?
I really like the Pokemon fan one. Are you a Pokemon fan, Denise?
Oh, absolutely. I've been a Pokemon fan since Pokemon Red and Blue, since the old school ones.
Andrea Pereira asked, what are the major red flags you, as the candidates, look for when you are interviewing for a software engineer position?
Oh, that's a good question. I think the red flags are different when you're a junior versus a senior engineer. But for junior level engineers, I would say one thing, I don't know if this is like necessarily a red flag, but I would ask specifically about what mentorship structures are set up at a company. So I would ask, like, are mid-level and senior engineers, like, is mentoring junior engineers part of their criteria for doing well at their job? Is that literally on the career ladder for a mid-level engineer to go to senior, or a senior engineer to go to staff or principal or whatever is above that? Because I think companies, it's not like a guarantee that you'll be mentored, but it means that some incentive structure is set up so that someone else wants you to be successful. I would also ask about how you would relate to your engineering manager, because that's super different from one company to the next. In some cases, the engineering manager will be someone who also looks at the code, is like directly on your team and can review your code. In some other cases, engineering managers are on different teams entirely, or they're not assigned to teams and they just have a people manager type role. Early career, my preference is for an engineering manager to be to have higher context on the code that I write day to day and like know what I'm doing technically. So I found that I get better feedback and I grow faster when I have that more, when I have a manager who more directly knows what I'm working on, and I don't have to constantly tell that person, what's happening. So I guess that's not really a red flag. I don't think there are other red flags, but it super depends on what kind of company you're working on. But those two are my main ones. Making sure that someone else is incentivized to make sure that you succeed, and understanding how closely your engineering manager is going to work with you.
All right. We got another question. How is it to work on such a big software project as GitHub by Francisco Lima?
How is it like to work on GitHub? It's very overwhelming. I worked on Rails projects before, both like for other companies and for side projects. And when you work on something the size of GitHub, all of the things that you've learned about the framework are just no longer, okay, not all. Many of the things that you learn when you're learning the framework are no longer true at that kind of scale. So like the biggest difference is, the biggest thing I've had to learn is not necessarily like how do I write Rails a little bit differently, but just how do I write Ruby code and data access code that works for both one user and for 1 million users. So things like, I'll just kind of give an example that I worked on this week. So sometimes in any kind of application code, you might load an entire array into memory, right? Like you might say like, okay, here's a team, give me all of the people that are on this team. When you work with a product like GitHub, that might be 10 people, which would be okay, but it also might be 500,000 people, which like, if you think of all the we use Kubernetes-based deployments. So like sometimes it actually is a container somewhere in the cloud, but sometimes it's like a VM. It doesn't really matter. Like the host that that request is hitting, sometimes like having such high memory consumption can knock a host over. So you have to be like very, very aware of how memory use and how data access and how blocking and like reading and writing from the database especially is a huge one. You just have to be hyper aware of these things. Unfortunately, we have a lot of people who are experts in-house on this stuff, so I don't have to know all of it, but I do have to demonstrate some awareness that I'm thinking about these things every time I open a pull request into the main monolith. So yeah, so like writing code at scale has been the hardest part and the most interesting part of the job, I think.
Well, there's a lot of questions, so I don't think we have time to get through all of them, but we have time for a couple.
Yeah, I have 3 or 4 minutes. We can do a few more.
Ricardo Xavier asked, what would be your advice to a junior when she/he is out of tasks and waiting for new instructions?
Oh, that's such a good question. If you're out of tasks, what I would do, which I don't know, the first thing I would do is actually ask another engineer on the team. I would say like, hey, is there something useful that I can learn about that would be used is there something that we're going to be working on soon that would be useful for me to learn about? And usually like any engineer on the team will be able to say like, oh, I know that this thing was really hard for me to learn. Maybe you should go learn about that. If that option doesn't exist, then what I would do is like look ahead at the roadmap or look ahead at the backlog and see what's coming up. And not like start working on the stories, but start reading ahead. So if you know that your team is going to be working on, some new database access or something next week, start reading up on how to use that database and how other companies are using it, or like that's kind of abstract, but less abstractly, you can just read other parts of the code and, do the time box experiment again. Don't let yourself spend like 3 days on it, but spend 3 hours on trying to figure out it, learn a new part of the code base, write up what you've learned, and then try to validate that with someone else on your team. I think like kind of guided learning like that is always going to be useful.
That was a very insightful answer. We have time for one more, I think. William Ribeiro asked, what's your opinion on companies that don't have seniority levels and everyone is just software engineers with different paychecks?
Well, I have strong opinions on this, but we have so little time. Okay, so...
We don't have a lot of time, so...
Yeah. In some cases, it can work well. In my experience, So there's a danger to both sides, right? Like there's a danger to having too many levels, because then people expect to be promoted every year and you get title inflation, and someone's like a senior principal staff engineer after 4 years, which like I don't think really makes sense. I don't think that's a meaningful application of that title in most cases. Like, of course you can be a genius 4 years in and like actually be at that level. But I'm like Microsoft, for example, which is the parent company of GitHub, has way more levels than we do. GitHub only has associate, software engineer, senior, staff. We only have 5 or 6. Microsoft, I think, has like 16 or 17. It's a different system, like, and you'll be obviously promoted less frequently with fewer levels. So it can feel frustrating to be stuck at the same level for a couple of years. I think the danger of having too few levels, though, is the main thing is negotiation, actually. So companies have minimums and maximums based on their levels. Every single company will have those. The minimums and maximums will be different based on your geography. If there is only one band and the minimum and maximum is like so wide that it's basically meaningless, you're going to have a harder time negotiating. As a junior level as an entry level engineer, you're not going to be able to negotiate that much anyway. But like after 3 or 4 years in the industry, that is something you're going to want to think about. For me, I went into GitHub as a senior engineer, and my salary automatically went up by, a significant amount from my last job because I was going into the senior band. If that didn't exist, I'm confident that I would not have been offered that much. I would have had to work harder to negotiate my way up there. So that's the main danger. The main danger is like unfairness in compensation. But this is a big topic, and I'm happy I'll check in on the chat later today if you have questions, and I'll try to answer some questions asynchronously over the next few days. That's a very, very big question, and I'm glad that you asked it. Yeah, I have a lot more thoughts on this, but we just don't have time today.
All right, Denise. Thank you so much again for the presentation and for this insightful Q&A.